Hello, my name is Dr. Charlene Ortiz. I am a doctor in clinical psychology with a specialty in forensic psychology. And today I'm going to be discussing the scientific method with a particular focus in the social sciences. Within that, we're going to have a more significant focus when it comes to the field of psychology. Now, if that's something that interests you, please stay along and follow the rest of the video. Now, this video is intended for persons who are in an entry-level psychology or in an undergraduate course in the social sciences. So if this applies to you, you're also welcome to stay with us. Now, let's go to our slides. Now, something that I must mention is that this particular presentation, if you're part of my class, you're also welcome to follow along with our slides that are posted in our course and also with your reading of chapter 2. Now, what is the intent of this presentation? Well, first and foremost, we're going to talk about the research methods. What are research methods? What type of research methods are commonly used in the field of psychology? What are the advantages and disadvantages of utilizing these research methods in order to answer research questions that pertain to human behavior? We're also going to be talking about the scientific method. And of course, this is going to have a focus within the field of psychology. Why exactly do we need to utilize the scientific method in psychology? And what exactly does psychology do in regards of it being a complete field of science within its own merit? Now, one of the things that I must mention is that the primary difference between other methods of understanding the world, for example, intuition and common sense, the problem is that these types of information the type of information, I should say, that we can gain from those methods is not necessarily accurate. For instance, because they can be based on a gut feeling. The difference, however, comes with the scientific method. What do we mean by that? Well, the scientific method, the intent is to understand information and gather data and information in a way that is less biased, that can actually be substantiated with evidence in order to have proof of a claim. So, for example, if I were to claim that all people are purple, just using intuition might not be necessary because there could be a skin condition that people could actually turn purple. So that's one of the main reasons why we have the scientific method, is to not have to rely on common sense and not having to rely on intuition or word of mouth in order to understand the world around us. But what does that mean? It means that we have to have critical thinking. What does critical thinking imply? Well, critical thinking involves a level of skepticism. And in this sense, basically questioning everything, every piece of information, every source, every author, every data that was observed, every data that's collected, written down, and studied. The importance of having critical thinking is removing factors of authority. For instance, just because we heard a piece of information from someone we believe is in a position of authority or someone who we believe is knowledgeable, that's not necessarily enough to substantiate a claim. So we must have critical thinking in order to understand information and understand that it's coming from an accurate source. Because of that, it's immensely important that critical thinking is the core, the foundation of the scientific method, because with the scientific method, we can start ruling out and eliminating factors that may not necessarily contribute to science because they were biased or they have much error that cannot be disproven or that cannot be addressed through science. That particular factor is what makes the scientific method objective. It makes the scientific method unbiased, because scientists, including psychologists or individuals who research under psychology, notice that their primary objective is have information and collect information that is unbiased. Because irrespective of my own thoughts and my own ideas, when it comes to research, that type of thinking is absolutely not enough. I need to have an objective mindset, and so are students. Students should also have an objective mindset, especially when reading data and collecting data themselves later on during their graduate studies and hopefully during their doctoral process. Now, something really important about the scientific method is that we are interested in controlled observations. Why are we interested in controlled observations? Well, something immensely important about having a controlled observation is, for instance, when we're conducting an experiment, we want to have a controlled observation because there could be factors that may muddy the results or the data that we're trying to collect with an observation. Now, a lot of people confuse the term observation because in the colloquial sense, we think that observation is something that we can look at, right? It's something that we are simply gazing upon. In sciences, however, what we mean by observation, it's something that we can either observe directly or indirectly. And what do I mean by that? Well, how do we observe something directly? So think about an accident, right? So for example, if you're driving down the road on a snowy day and you see a car that is off the road and this vehicle you can see the tire marks on the snow, you can see how it hit the tree, but you weren't there to see the actual accident. However, you have enough pieces of evidence, for example, the tire marks on the road, the tire marks on the snow, the tree on top of the car being destroyed. You have enough pieces of information to conclude that there was likely an accident, that you're actually witnessing the aftermath of an accident. So that's something that we would consider indirect observation, and that would be acceptable in the field of science. So a lot of people confuse the observation term, meaning that the scientist has to actually physically see the actual event, but sometimes we can have enough information to where we have enough evidence that substantiates our claim that yes, there was in fact an accident here, even though I was not there to observe the accident occurring. Now, of course, in the social sciences, we actually have a thin line. There's a very thin line between being able to observe something directly and not, particularly when you're dealing with your own clients. Clients are going to have claims, for example, of abuse, but we weren't there to observe the abuse. So notice that we can gather evidence to substantiate the client's claims. So for example, descriptions of their symptoms, descriptions of the events. So notice how we don't necessarily have to be present in a situation to have a conclusion or a confident conclusion that something will happen. Now, of course, that veers towards the forensic psychology side of things. This is a very broad generalization of what that means, but whenever you decide to move forward to other fields of psychology, like forensic psychology, witness testimony, and claiming a certain form of attack or abuse, you will get more insight as to how reliable this type of information can or cannot be. So let's continue back to our slide. Now, something immensely important that's really very much significant in the field of the scientific method is the ability to develop a testable hypothesis. Now, this term, the fact that we are doing a testable hypothesis, what does that mean? Well, a hypothesis is basically a prediction, and we're going to discuss hypotheses in much detail later on in this presentation. But something that we need to remember is that in the scientific method, we have to develop testable hypotheses. And why is that? Well, often we hear a lot about hypotheses that cannot be tested. If I am not able to test a hypothesis, then that hypothesis is actually no good. Because the point of science is the fact that we want to get rid of the hypotheses, whether or not we are accepting something or rejecting something. So if we cannot test the actual hypotheses, then it's absolutely worthless. That is why we must develop a testable hypothesis. Now, generally, how is it that we test the hypotheses? The first thing that we can do is actually try to manipulate a variable. We want to make sure that we are able to manipulate whatever it is that we're trying to test. So for example, if I can change the temperature in the room and see the client's reaction or a student's reaction in that setting, for example, if I was giving therapy or if I was doing that to a student, notice how I am able to manipulate the variable, which in this case was the temperature. Now, another important term is how. How exactly are we going to measure the specific outcome? So for instance, if I'm trying to figure out if there was indeed an impact on the students, for example, they perform poorly in their exams whenever the temperature is pretty high, when it's pretty hot, how am I going to measure that variable of being upset? What instrument am I going to use to make sure that I can accurately measure the variables in place? Now, the next thing is consider, I should say, reasonable alternative explanations. Why is this important? Because remember what we were talking about earlier when we are thinking about critical thinking, we also always want to eliminate our own expectation. So for example, I can be immensely focused on a result, right? I can have my own prediction of a hypothesis, but I need to look at evidence to the contrary. What actually negates my own research? What negates my own study? In doing so, I will have the ability to not only show the side to the contrary, I can see whether or not there is merit in the other side, in the alternative explanations. And if my actual research stands that type of scrutiny, we are able to say, yes, the data collected in this particular research is substantiated, and facts that, or information, I should say, presented to the contrary did not stand the scrutiny. Therefore, those alternate explanations will not be considered because they don't stand the test of having it been evaluated by critical thinking or further research. So let's move on to our slide. Now, importantly, something about the scientific method is that the scientific method is a process. It's actually a set of steps that must be conducted in order to test the information that we are looking for, to see whether or not this information is accurate. And something that we need to understand is that these steps are important because if we are not able to conduct each step in a rational and empirical way, meaning that we can actually test them, then unfortunately that method would be flawed, and therefore the information that you collect would undoubtedly be pretty much, at the very least, it will be compromised. Therefore, it could have room for bias and error. So the first thing that I'd like to talk about is the hypotheses. Now, as I mentioned earlier, hypotheses are a prediction. So in going back to the example that I was giving earlier, if I decided to raise the temperature in the classroom and say this is going to have an impact as to the anger that students may experience during test taking, notice that I can make a prediction about that. So for example, I can say the higher the temperature, the more likely that the student is going to be upset. Or I can also say the higher the temperature, the more likely that the test taker, that the student is going to perform poorly. So notice that a hypothesis involves a form of prediction. It actually involves how do we think one manipulation of that variable is going to translate later on to the rest of our research. Now, in order to test a hypothesis, remember that hypotheses have to be testable. We must conduct research. We must conduct research that is able to test whether or not that hypothesis stands true. Before we conduct research, we always have to design a study that we believe is actually the correct method to answer a specific question. So having said that, we will discuss in detail what aspects are required and what types of questions are better for answering a research question. Now, the other thing that's interesting is then we are going to conduct our actual observation. We're going to look into and see what type of data are we collecting. So for example, if I am making an observation of, say, for instance, the temperature, now I can conduct data, now I can collect data, I should say. I will look into the changes in temperature. I can look into, say, for example, the reactions of the students, collect data from an instrument that I might select, that I should select before the study. So for example, how to measure anger. And later on, I have another instrument, which would be the one that I will collect the test answers from. So notice that here, I'm going to observe the data. I'm going to observe the event that is actually leading to my research question. Once again, is it in fact going to answer my research question, or do I have evidence to support my hypotheses? Now, the last thing that I would like to share in regards to the scientific method is later on, we can create or modify a theory. Now, the term theory generally hits the ear wrong, right? It hits the ear wrong for the average person, because sometimes when we hear the term theory, we think that it's a guess, right? We think that a theory is not a set of understanding. Generally, when we hear the term theory, so for example, I have a theory of where Bob went this last weekend. Generally, when we hear that term, it almost sounds like a guess. It almost sounds like something that we're not sure about. But in science, however, this term, the term theory, so for example, the theory of gravity, the theory of evolution, these terms, what they mean is that a theory is a set of facts and information that we use to understand a phenomena, because they have passed the test and scrutiny of science before. So what we do is that we grab different sources and different data that corroborates the theory, that actually supports the understanding of the phenomena. And once we have a clear understanding of these processes, and we can use them to make predictions and our comprehension of a phenomena, that is when we have a theory, because a theory, it's a set of rules and facts that allows us to understand a phenomena. So for example, the theory of gravity, we have a set of rules and understandings of that particular phenomena, which in this case would be gravity, and we can use it to make predictions about gravity. And the same thing would go with the theory of evolution. We have data and evidence to show proof and an understanding of how is it that species adapt from one species to another. So we would have a clear understanding. So notice that the term theory in science actually means something immensely different than the term that we may use in our everyday language. So I do want you to keep in mind that in science, the term theory means a comprehensive set of evidence that we use to understand a particular aspect or a phenomena. Now let's go back to our slides. Now, something that it's also significant and that is very important is how is it that we conduct observations? How is it that we conduct reasoning in order to understand an observation? So in this example that I am showing in this slide, I want you to notice that we have different forms of conducting our reasoning, of conducting our observation. So we have deductive reasoning. What do I mean by deductive reasoning? Well, in deductive reasoning, I want you to look at the empirical observation, right? So we conducted our observation. Let's go back to the example of the car accident. The car accident, we saw the tires, the tire marks on the road. I saw the tire marks on the snow. I saw that the car, it's pinned under a tree and it fell on top of the car. So because I have information that was unbiased and then went through scrutiny, for example, the investigator later on that shows up to the accident, to the scene of the accident, notice that he can conduct a deduction. And what is that? We're going to deduce, we're going to have a rationale saying from this set of data, from this type of information, I'm going to conduct a deduction. I'm actually going to use deductive reasoning. So from a set of larger data, I'm going to draw a conclusion. On the other hand, we can do inductive reasoning. What do I mean by that? Well, I can have a general idea of, for example, what a accident looks like. I can start thinking about this is what I expect from an accident. I expect to see glass. I expect to see tire marks. I expect to see, for example, maybe people who have been hurt, damage to the car, damage to the road, maybe road signs. So I have basically an idea. I have an idea of what it's going to look like, an accident would look like. So notice that now I don't have the observation, but I have the idea of what that's going to look like. So now I'm going from the opposite direction. So now I'm going of having no observations. And now let's try to collect data and say whether or not that idea is substantiated by empirical observations. So notice that in deductive reasoning, we have that type of information. We're going to have that observation, and we're going to draw conclusions. Whereas with inductive reasoning, we have an idea, and then we're going to go back and look at observations and conduct our own studies and see whether or not these have been substantiated. So that's a form that we can conduct our own research. We can draw conclusions based on inductive or deductive reasoning. We can either see it from our empirical observations, or we can draw those conclusions based on our ideas that were later substantiated by an observation. But let's go back to our slides. Now, interestingly, this is usually a point of debate, right? This is something that we can see often, especially with people who are not in the field of any science, whether it be one of the hard sciences, so for instance, physics, biology, or the softer sciences, for example, sociology, psychology. Generally, we see a lot of point of contention with this term. Now, something very interesting is that generally we can consider research in two ways. For example, the first way that we conduct research, whether it be in psychology or in another place, in another field, is basic research. So what do I mean by basic research? So over here with basic research, we're basically conducting research just for the sake of knowledge, just for the sake of an understanding. So generally, what we are trying to do is conduct the building blocks. We are trying to get information for just an overall understanding of a phenomena, but not necessarily to deal with the phenomena. Now, the issue with this type of research is that many people contend that knowing for the sake of knowing is not enough, that knowing just because we want information, it's not enough of an issue. So for example, some people may say, well, why do we need to study the reproductive behavior of bees? Why is that important? So a lot of people, especially with funding, would say, well, that's a waste of money because we're trying to get data just to get data and expand our knowledge. But what are we going to do about it? What exactly can we do with this type of information? Right? So that's where you find that point of contention, whether or not this type of research is important. Now, for people like us who are in the social sciences field and our peers in the harder sciences, we do consider this information important because without a foundation, without knowing what information is, what a phenomena is, we won't be able to help. We won't be able to find out information. So for instance, in looking in our peers in the hard sciences, so for example, with physics, At some point, we had no idea what gravity was. Absolutely no idea. But at some point, people started conducting studies about the phenomena of gravity for the sake of knowing what gravity was, not necessarily to use that information to apply it. But without that basic research, we would not be able to do many of the things that we do right now. So for example, understanding wind resistance, or being able to send a ship with NASA to the moon, because we wouldn't even have the understanding of what that phenomenon was in the first place. So notice that basic research is indeed important. We actually need it to understand and have a foundation of a phenomena, or of something, or an event, or something that we are interested in, because we simply don't have enough information. So whenever we are exposed to new events or new data, for example, let's use COVID as a potential example. We had no idea how people were going to react to the events of, for example, being isolated because of COVID, or not being able to say goodbye to their loved ones when they were in the hospital, because of course their family members were quarantined and exposure to them would have been too dangerous. So notice how we didn't have information about that. So there was basic research conducted because we needed information for the sake of knowing what was happening, not necessarily what we were going to do about it. Now, of course, we're going to move on to the next type of research. So let's go back to our slides. Now, we discussed basic research, but now I want us to look into applied research. So basically, I almost like to think about that as basic research as step number 1, and then applied as step number 2. Now, keep in mind that might not be the case for many of the research approaches, but I do want you to keep that in mind. So once we have basic understanding of a phenomena, once we actually understand what's going on, we can actually start doing things in the applied side of things. So what do I mean by that? When we are thinking about the applied side of things, we're actually trying to solve a problem. We're actually trying to see what information do we have that we can utilize to help and address a problem. So for example, we're trying to look into some of the areas that in science we can use to help people, especially in the side of the social sciences. Now, keep in mind, this could include clinical areas. For example, what my foundation is, which is clinical psychology. We can deal with human factors, with industrial and organizational psychology, educational psychology, and psychology and law, and health psychology. Notice that all of these fields are not theoretical. These are not fields that are trying to learn for the sake of learning. They're actually trying to use that information that we didn't learn about in the theoretical side of things. So for example, in experimental psychology, and now we're trying to use that information and translate it into everyday life. So for instance, if we had no idea how people were going to react to aspects of COVID-19 and their family members being basically in a hospital bed without having access to their family members before their passing. Now that we have that basic information, now we can move forward and conduct other types of research, in this case, applied psychology, to understand their phenomena, to understand what's going on and what can we do about it? What can we do to help those clients, those patients, those research participants? How can we help these individuals based on the information that we do have? Now, some of the things that we can look into, especially in the field of psychology and law, which interestingly is my specialty in forensic psychology, is, for instance, we want to investigate factors involved in eyewitness testimony. Now, there are many factors that could contribute in the area of witness testimony, particularly how accurate is the testimony overall, and details, even if the witness testimony is immensely accurate, what are the impacts of having to stand in front of a jury and having to sit in front of a judge? Because that factor can also have an impact on their testimony, whether or not it was recorded, whether or not the defendant is present, whether or not the defendant is trying to make some remarks during the proceeding. So notice that we are trying to use that information in a real life, in a real case. So for example, individuals who have to testify. Now, another example would be, let's analyze methods that will encourage people to learn better. What things can we do to understand and help the individual through applied research and help them later on in their application of that research? Now, something immensely important of both these research methods. So for example, our basic and also our applied that we were just talking about earlier, just now, we also need critical thinking. And in this type of critical thinking, when we are exposed to either basic or applied research, you need to understand what exactly is the expertise of the person making the claim through their research. Now, as I mentioned earlier, the authority and aspects that involve the person, we need to question that, because just because a person said something and we truly believe them to be a matter of authority, doesn't necessarily mean that that is the case. Now, by the same token, I wouldn't expect a psychologist, or let's use another example. I wouldn't expect a celebrity to know anything about court proceedings, right? I wouldn't expect them to be an expert in how to analyze data in a field of legal aspects. So notice how, yes, we have to question these types of aspects, but also keep in mind that there's also an expectation as to what is the expertise of that person making the claim. Now, another aspect of critical thinking is, what is there to gain? What is this person going to gain if based on their research? What are they going to gain if their hypotheses are tested and they are corroborated, if their research questions are answered? We need to understand what matters, what things can this person gain should this research, or should this researcher, I should say, have a vested interest. So for example, say I publish something about, say, legal matters and aspects of, for instance, people who may try to do a plea of not guilty by reason of insanity. So notice that if I'm conducting that research, what is there to gain on my end? Am I doing this research because it's going to help the development of science and its application? Or am I doing this research because I'm going to have a personal gain from this research? So that's a really important point when it comes to critical thinking. Is there a gain from that researcher? Are they going to gain something because of the research? Now, when we are using critical thinking, another really important point is, whenever a person is making a claim, they conduct a research and say, the hotter the temperature is of a room, the poorer or the less effective is the test taking for these students. So notice how we also have to question, is this claim backed up by the evidence? Do we actually have enough information to where this person can actually claim this claim? Can they actually substantiate their claim? Now, we can do that by looking into their research methods and seeing whether or not they collected their data correctly, and if the person was actually correct in claiming those things. So for example, if I say, yes, I conduct my research and I say the hotter the room, the less accurately are the answers for that test going to be, but then my research doesn't substantiate that. My research didn't find a significant difference between persons who were in a hot room versus persons who were just in a room temperature classroom. So notice how, if I'm making that claim, I should have enough evidence to back that up within my research. We can also do this by seeing whether or not this aligns with the rest of the information that we have from other previous research. So notice that, yes, it is immensely important that you also question, is the claim substantiated of everything you read, especially in research? Now, lastly, when we use critical thinking in regards to research, we need to understand what is it that the scientific community says. Is my claim aligning with the scientific community? Now, as I mentioned earlier, you always want to question everything. So for example, if there is a consensus on how gravity works, right? There is a consensus, I should say, in the field of physics and physicists, there's consensus of how gravity works. So for instance, if I develop a research and it turns out that I can demonstrate that gravity doesn't work a certain way, we need to look at why exactly is this not matching the consensus? Because sure, it could be that you made a mistake, whether it be honestly or dishonestly, but it could also mean that you have enough evidence to show that that theory needs to be revised, because science is about revisions. Science is about questioning. So it doesn't necessarily mean that the person is lying, or it doesn't necessarily mean that the community is lying, but it could simply mean that the theory needs to be revised. Now, how do we do that? We do that through the process of peer review. We do that through the process of replication. So other people are going to question your piece of presentation, your piece of research, and they will do them themselves to make sure that it was actually accurate. And now we have a point of contention that could be actually revised. So it's not a matter of opinion, it's actually a matter of trying to revise that research. So those are the points that I would like to bring up when it comes to critical thinking, and how does that look like? How can we apply them, if you will, just like we were talking about basic research and applied research? How is it that we can actually apply them for the participation of critical thinking? So let's go back to our slides. Now, in regards to a theory. Now, a theory, as I mentioned earlier, is a way to understand. It's a set of evidence of well-developed ideas that propose an explanation to a phenomena that tries to explain why are things the way they are based on evidence that we have collected in the past, and evidence that keeps coming in order to revise that theory. Now, for example, a way would be algorithm, right? So for example, we can use that as a construct and say, hey, this is how we are going to understand altruism, and we're going to define it as helping behavior, I should say. So we're going to move forward, I should say, on understanding this type of phenomena. Now, I also talked about hypotheses. Hypotheses are just a prediction. They are a prediction on how that theory will work, right? So for example, I have an idea, and how is this information going to go? What am I expecting from those findings? Now, theories generally organize principles, right? So generally when we have a theory, we will have a set of laws, and we will have laws that are going to theory, inside the theory, in order to provide that construct, in order to have that understanding later on, to have evidence and proof of this phenomenon and how it works. Now, lastly, we also have models. What is a model? It's basically a framework. We're going to understand how things work, how things operate. So for example, I could have a framework of cognitive psychology, or I could have a framework of neuropsychology or biopsychology. I could have a framework of humanistic psychology, because I'm trying to use a model to understand how something works. So for example, I can use a humanistic model to understand alcoholism. I can use a cognitive behavioral model to understand alcoholism. And generally, when we use a model, we're trying to use the one that better fits the event or the phenomena that we're trying to observe. Now, I can hear you. I can hear you say, well, if we're trying to pick one or the other, means that that theory wasn't good enough. Now, that's actually not true. Just because we're using different theories doesn't mean that that theory is poor. It's like saying, well, if you have to use a hammer to nail a nail to the wall, that means that you couldn't use, for example, a shoe to nail that nail in the wall, because that shoe is not intended to explain that phenomena, right? So for example, I'm not going to use the theory of evolution to explain gravity, right? Because one theory is not intended and it doesn't have evidence to substantiate what the phenomena is. So for example, you're not going to find anything in the theory of evolution that's going to help the explanation of gravity, right? So we always use a model that actually fits the explanation, right? We try to utilize it so that it can help you understand a phenomena more clearly. Now let's go back to our slide. Now, interestingly, in psychology, we have moved from theories, right? And what do I mean by that? Well, initially, we were trying to explain mental illness. For example, the ancient Greeks, whenever we had someone who was sick, or whenever we had someone, say, for example, who was schizophrenic, they only knew what they knew, right? So that's why I said that theories and models are revised as new information comes in, because science is about developing and rejecting incorrect ideas based on the evidence that we have at that moment. So for instance, the ancient Greeks would explain mental illness in the sense of the four humors. What do I mean by that? So if you look here at your bottom left, you're going to see that they would attribute the yellow bile to fire, and they would attribute black bile to earth, and so on and so forth. So they believe that all humans had all four of these, and having an excess or having a deficiency of any of these four biles, that's when people started to have mental illness. So for example, if they had a lot of blood, they may have a lot of anger, so maybe we need to drain them from their blood. And that's actually what would happen. They would move towards that type of direction because they sincerely thought that that was the explanation of the phenomenon. Now, if someone is being drained of their blood, I'm sure they would calm down because now they're not going to have enough energy, right? So if we're having someone who's having a psychotic break and now we're draining their blood, notice that for them, it worked. So it must be right because it did work for all intents and purposes. But of course, we know that schizophrenia has other explanations because we revised that model. We revised the model of the four humors. So for instance, we started moving, say, for example, during the Renaissance, we started to believe that our mental health was related to water statues, basically that there was a form of hydraulics that could explain mental illness then. Now, the next thing that I would like to mention is then once we were moving towards the 20th century, we started comparing our nervous system to a switchboard. So for those of you who may be too young to remember things of that nature, initially, when you make a phone call, you would contact the operator and the person would physically link you to the port that belonged to the person that you wanted to talk to, and then your call was transferred there. So our understanding of the nervous system was pretty similar to our understanding of a switchboard, basically trying to connect one line with the other. That's how we were trying to explain, for example, synaptic connections in our nervous system. Now, currently, something really similar to the more recent understanding, say, for example, in the 20th century, we started seeing our nervous system as a computer because we were starting to link, for example, one nerve to the next, and it was easy to understand why people would think that the nervous system would be related, so insofar as how a computer system is related. Now, as I mentioned earlier, we're going to talk about a hypothesis much more in detail. Now, importantly, most importantly, we need to, as I mentioned earlier, to have a hypothesis that is testable. If a hypothesis is not testable, then it's useless because we cannot work with that hypothesis. Our whole point is to reject the hypotheses. The more we try to reject a hypothesis, the more likely we are going to find the adequate explanation to a phenomena. We're more adequately able to make a prediction, I should say. Now, I mentioned that a hypothesis has to be testable. But a hypothesis also has to be falsifiable. I actually have to be able to falsify a hypothesis. And why is that? I have to make sure that I can reject, that I can say whether or not this hypothesis was false. If I am unable to say, yes, this is false, this is incorrect, then the hypothesis is also useless. That hypothesis is actually not adequate to test the research question and to make the prediction, I should say, towards that research question and that phenomena that we're expecting or not expecting to see as a result of our intervention. Now, the thing about a hypothesis is that it's going to show you, the hypothesis is going to show you how the world would work should the theory be correct. So for example, let's go back to the theory of gravity. So if I have an understanding of the theory of gravity, I should say, and how gravity works on Earth and how does it work on Mars and things of that nature, I should be able to continue and being able to revise and evaluate whether my theory, the theory of gravity, was correct. So notice how a hypothesis also helps people into revising a theory. Now, generally, a hypothesis would be accompanied with the term if then. So for example, if this is A, then if this is A, therefore B is going to occur. If this is A, then B is not going to occur. So notice that generally we will see them accompanied by that short little statement. Now, something really important about hypotheses is how are we going to consider the manipulation, right? So if we go back to our example of me changing the temperature of a classroom, if I change it, I need to be able to change that room temperature, I should say. I should be able to change it because I am trying to manipulate that variable, which is temperature. And that is a significant and key element of the aspects of research, especially with the matters of experiments. So I do want you to keep that in mind, that we should be able to manipulate the variable that we are trying to test. Let's go back to our slide. Now, something really important is we can see, and this is another really similar example, right? So we have the treatment changes the measurement. What do I mean by that? So if I'm trying to measure the room temperature, my change, if my hypothesis is to be proven, or rather not proven, it shouldn't be proven, it should be rejected is the term that I should use, which should be correct. So let's revise that, right? And again, just like in science, you make revisions as you get new evidence. So if I make a mistake, it's okay to revise it. So we should expect that if we are applying a sort of treatment, if we are applying a change, we should therefore see a change in the measurement. So if my hypothesis is correct, if the room temperature is high, the less likely the students are going to perform well, then I should be able to change that temperature in order to make changes to that measurement. So notice how I am able to make that measurement. Now, think about the relationship between variables, right? So in this relationship, I'm looking into, is there a relationship between room temperature and test performance? Is there a relationship between room temperature and anger in students? So notice that we are also trying to understand whether or not there is a relationship, and we will cover that in much more detail. Now, something really important in looking into this aspect here. So let's look into this little annotation here. We have H1. Now, what is H1? That's something that we like to call the alternate hypotheses. I've heard the term alternative hypotheses, right? So remember, we want to make a hypothesis testable. So when we have a hypothesis, we can say, if this, then that, because there will be a change. That is your alternative hypothesis. It's generally the one that tries to predict if there is a change. However, we also have the null hypothesis, and that's generally expressed by an H superscript 0 or superscript O, and that's what we like to call the null hypothesis, right? So basically, this hypothesis says there is no change. There is nothing that is going to happen to that measurement. There is absolutely no change, and it's going to remain the same. There's nothing that is going to change. But my alternative hypothesis says, no, wait a minute, I am going to predict a change. I'm going to see something different. So notice that this is why we say that a hypothesis has to be falsifiable. A hypothesis has to be prone to a rejection, because we are trying to reject this hypothesis that there was no change. Now, in more detail, when we are talking about the null hypothesis, the null hypothesis means that the treatment will have absolutely no effect. It's actually not going to contribute to any of the changes. So for instance, in the example that I gave you about changing the temperature, the null hypothesis would say there will be no changes on the effect of the temperature towards the students. There's simply no change in their anger, simply no change in their test scores. So that's what the null hypothesis is. So remember, a null hypothesis implies absolutely no change whatsoever. Now, generally, when we have a group that we are trying to measure whether or not there was changes, we also want to include a control group. What is a control group? A control group is simply a group that is not exposed to the treatment, that is not exposed to that independent variable. So for example, I have a group of students here who I have exposed to changes in temperature, so whether or not it's hot, and I have a group of students here who are simply there in room temperature. So this group here would be the control group, whereas this group is what we would utilize to understand the treatment that is not equal to the control. So what do I mean by that? Now we're going to move forward to our alternate hypotheses. So what this means is, here we stated, regardless of the room temperature, there's not going to be a change in that group. Whereas in our alternate hypotheses, we're saying, yes, there will be a difference. There is actually a difference. So if I have a group of people who are exposed to hot temperature, that means their scores are going to be poor, or another hypothesis would be that their anger is going to go up. So notice this is an alternate explanation as to whether or not there was any change. So something that I need to point out is, what we're trying to say is that the treatment did in fact have an effect. The treatment, for example, changing the room temperature, giving you a pill, actually had an impact on reducing your symptoms. Going to therapy actually had an impact in reducing your symptoms. So, or, something a little bit easier to understand would be, if you take safety measures in the car, then it's less likely that you will have a car accident. So notice that the treatment did actually have an effect. And what we're trying to do, what we are trying to do in this scenario, in this explanation that I'm trying to demonstrate here, is each of you to notice how the null hypothesis implies a control, implies no effect, whereas in the alternative hypotheses, we're trying to see, yes, there was an effect, and this is what it looks like in comparison to the treatment, or I should say rather the control group. Now, interestingly, how do we measure these differences? Well, we're actually going to measure them through an experiment. We're actually trying to identify what the differences are, whether or not there's a difference between that control group, the group that had no influence and no changes whatsoever, versus the group that we are trying to find out whether or not, yes, there was an actual change in that, in the expectation, in our prediction of whether or not something was going to happen. Say, if I change the room temperature, they're going to be angrier. If I increase the room temperature, they're going to perform poorly in their exam. Now, something that we need to understand about what science tries to do. What exactly is science focused in? Well, something important to understand is that the goal of science is to describe. The goal of science is to understand the information, the phenomena that we are exposed to, or the phenomena that we encounter. So there's multiple ways to do that. For example, in social sciences or in other sciences, our counterparts in the hard sciences, we can use different methods. So for example, if we are trying to make a prediction, if we're trying to say, if we were trying to say and describe a phenomena, we would like to conduct a naturalistic observation. If we're also trying to describe a phenomena, we are going to conduct a survey, because naturalistic observation, or basically, this is just a term to say observing things as they are, as they occur, right? So for example, think about observing a group of 5-year-olds in kindergarten, right? So we would like to observe 5-year-olds in kindergarten, in their kindergarten classroom, without any intervention whatsoever. We want to observe them just like they are, quote, in their natural habitat, end quote, because we're trying to see how they would behave naturally. How are they going to behave in a very basic aspect? Now, a survey can do the same thing. A survey can allow us to describe. So for instance, many of you have probably conducted surveys before, or you have conducted surveys for fun, you have conducted surveys for school, surveys about your political views. So many of you have conducted surveys before. That is because we want to be able to describe, for example, your political stance, right? So you can take a survey to see whether or not you identify closer to the Republican Party or the Democratic Party. But surveys can help us make a description. The next point that I want to talk about is another goal of science, which is predict. Science wants us to predict the outcome or something that can occur. How do we do this? We do this via correlation. What is correlation? We're simply trying to identify the relationship between one variable and the other. So for instance, let's say I'm trying to make a prediction as to whether or not, in one of the examples that I found recently in your textbook, was saying if a woman, and I'm going to be very artistic here. So let's say that we have a woman that wears red. So we were trying to figure out whether or not her male counterparts would spend money on her, right? So a prediction would be, the redder the dress, the more likely is a gentleman. We're going to draw little ears on him and everything. And his beard doesn't look like a beard, does it? Here we go. So a prediction would be, the redder the dress, the more likely she is going to be asked out for a date, for instance. So that would be a correlation. Now, this is where we have to draw a very clear distinction. So if you take nothing else from this presentation, I need you to understand that a correlation does not imply causation. I'll say that again. A correlation does not imply causation. And why do I say that? Well, it's because a correlation, even though we can have a really strong correlation, say the redder the dress, the more likely that she's going to be asked out because the color stands out. Notice that irrespective, regardless of the color of and how strong this relationship is, we cannot say that that is what caused her. to be asked out for a date because a correlation does not imply a cause. And I'll give you a great example of a correlation. Then this is actually a true correlation. So there's correlation between shoe size and how well you perform in a test, right? And you're thinking, well, how does that make sense? What does shoe size have to do with me performing better in a test? Well, the larger the shoe size, the more likely a person is able to pass an exam. And you say, well, that shouldn't happen. There's no cause. I can't see the cause in it. Well, because it's a relationship. Now think about this. A kindergartner would have a very small shoe size. And if I give him or her a calculus exam, it's less likely that they will pass. Whereas an adult has a larger shoe size, and if I give them a calculus exam, they're more likely to pass the exam because they actually went through school or they went to college, so they know a little bit more about math. So notice that there is a relationship there, but there is no cause. There is a relationship because the older the person, the more likely that they've been to school. So the cause would be education, whereas the relationship here was shoe size and how well they perform, for example, in a calculus exam. So notice that a correlation never implies causation. So if you take anything from this slide, I really hope that it's based on this. So the next thing that I would like to talk about is experiments. Now, this is what actually can be used to understand the cause of something. When we actually want to see, yes, there is a cause, there is something that we can pinpoint that has caused this type of outcome in our variables observation. So an experiment is basically trying to manipulate that variable while having a control. Now, if you remember from our previous slide, if we would have, for example, and I'll share this with you. So let's think about an experiment. So within an experiment, we're going to see that, say, for example, we have one factor, right? So for example, we have individuals who are not going to be given a pill. So we will have no pill, and then we will have pill. So we are going to observe, for example, what are the reactions? What is the symptom reduction? What aspects are occurring? Because we, in fact, do have control of a pill. We do, in fact, have control, say, for example, of the amount of milligrams of that medication is going to have for the chemicals. We control the molecular structure of a pill and its chemistry. So notice that I do have control. I have control as to when am I going to administer this pill? What are they going to be doing? So I actually have control of how that intervention, about how that treatment is actually going to be implemented later on with that group or those people. Now, you can argue a placebo effect, which we will be covering later on in other lectures. But notice that the takeaway from this idea is that I have control. I, as the experimenter, I would have control about what is going on with the experiment. I have control over that variable. Now, I can also measure the differences between the group that had absolutely no pills, no pill whatsoever, versus the people who were given a pill. Now, I would like you to consider what explains what actually is better for some type of research. And ultimately, it depends on the research question. It will depend on what exactly are we trying to find out. If we're trying to explain the cause of something, why something happens, then of course we will move towards the experiment. If we're just trying to see if something is linked, then we will go to a correlation. But if we're trying to look at, hey, how do things behave? How do people behave? What happens in a naturalistic environment? Or if we're trying to find out more information about a source, then we would go with a survey, or we would go with a naturalistic observation. And we're going to move in detail. We're going to move in detail as to what each of these approaches are. because, like I said, there's different methods that we can use that are going to help us understand each phenomena, right? So if I'm interested in learning about something in its natural environment, we are going to go to a naturalistic observation. We're also going to discuss clinical or case studies, which generally are the ones that you will see in the media, you will see on YouTube, and they found, oh, check out this serial killer. Look at how they were. Look at how special this person or unique this person was. So that's what case studies are, I should say. We're also going to talk about surveys. We're going to talk more in detail about correlation, and we're going to go in depth to the experimental side of things. Now, a naturalistic observation, as I mentioned earlier, is basically observing that behavior in its natural, typical environment. So if I'm interested in seeing how 5-year-olds behave in the classroom, my best bet would be to observe the 5-year-olds in their classroom, right? If I want to observe how people behave at the club, my best bet would be to go to an actual real club and observe them. So the good thing about a naturalistic observation is, first and foremost, it provides descriptive data. It allows me to describe these people and how they are behaving. Now, another aspect, another benefit of a naturalistic observation is that this type of observation, it allows us to observe the events without any, let's say, contamination, as your presentation describes. We're trying to look at this without the influence of other things. So for example, if I wanted to know what 5-year-olds behave like, right? Maybe they would behave differently if they were with their parents, right? But because they're not with their parents, they are in school, they're going to behave a certain way, right? So notice how we can control, or rather, let's use another term, I can understand that it's not going to be influenced by other outside factors. Now, interestingly, naturalistic observations are pretty good when it comes to something that may be controversial or something about actions. So for instance, let's think about how you would behave, right? Or how anyone would behave in front of their parents, right? So generally, people, when they're with their parents, they behave a certain way. Whereas if they're not around, if you are conducting some sort of behavior that may be controversial, so for instance, using substances, then you're more likely to behave naturally and to, say, for example, intake substances, because you don't have that outside factor that's actually contributing to changing your behavior. Now, there are some problems, however, with naturalistic observation. Now, the first thing that we need to talk about is observer bias. We need to understand the influence that I would have as an observer, right? So we may think, oh, if I observe the 5-year-olds in their classroom, they're going to behave like they normally do. In reality, if I am sitting in that classroom, they're going to say, oh boy, there's, Dr. Ortiz, I better behave differently because I don't know this lady, or because, ooh, there's somebody new, this is different. I can't behave the way I normally behave. So notice that I can actually have a contribution in their changes. Now, granted, in naturalistic observation, there's ways to mitigate this, right? Your own presence and how that may influence the behavior. Now, interestingly, think about how you would normally drive if you didn't see any police officers, right? If you didn't see any police officers, you're probably not as careful as you should be, right? But once you see a patrol car, or if you see some flashing lights, then okay, I need to behave a certain way because that has changed your natural behavior in your typical environment, the way you typically drive. So notice how, yes, having that presence will change your behavior. But of course, there's ways to mitigate this in naturalistic observation, and you will learn more about this in your more upper level courses in your undergraduate studies, and you will definitely review them in your graduate studies. Now, in case study, clinical studies, what is a case study? How are these beneficial? A case study is an examination of a behavior that is immensely unique. It is immensely special because it generally applies to a very specific situation. It generally applies to a very specific person, meaning that not a lot of people have been exposed or have gone through that same situation, or may have a unique event that only applies to them or a very small group of people. Now, something really good about this type of study is that we are able to provide a very descriptive analysis of a very rare phenomenon on something that doesn't normally happen. So for instance, let's say that we have a poor understanding of a person who lived a year after they were injured, right? After they had a very severe brain injury, it was a freak accident, and they have been the only person to survive that long walking around with that brain injury, and they managed to survive. Notice that this will be a case study because it's unique. You're the only person that has survived this injury. So of course, scientists are going to be really interested, I should say, in understanding that specific case. Now, there is a problem with case studies, even though they provide an immense insight in our understanding of a phenomenon, an event, a situation, or a person. Unfortunately, because it is so unique, it cannot be generalized. I cannot extrapolate that information that I have from that one person, and then we're going to move it forward to another individual or another population because it is so unique. It is not representative to the rest of the population. Now, I'm going to show you a case study, right, which is a situation that happened to a young girl from birth.
In 1970, in a quiet suburb of Los Angeles, a harrowing story came to light. It would change forever our understanding of how a child's brain develops. A social worker discovered a 13-year-old girl who was still in diapers and whimpered like an animal.
Clearly, something was terribly wrong. She didn't speak. She was completely unkempt. She could hardly walk. She could hardly balance.
Jeannie, as the child was named, had suffered a most horrific ordeal.
We learned after she was found from interviews with her mother, from some drawings that Jeannie made, that she had been kept isolated in a room at the back of the house. In this room, there was a potty seat to which she had been harnessed without any clothes, just naked, and left to sit there day and night. She was in this room for 12 and a half years.
Jeannie's father was mentally unstable. He had decided to hide his daughter from the world.
Mr. Wiley?
Yes.
Why did you keep your daughter in a room?
Mr. Wiley has no comment.
No
We
comment.
haven't had time to discuss the charts. We haven't even seen them. What about this?
Jeannie's parents were both charged with willful abuse.
I just can't comment.
15 minutes before he was due in court, her father put a gun to his head. But the damage to Jeannie was done. She had spent her childhood in almost total isolation. Her brain had been deprived of a nurturing environment and left to grow in solitude. The effect was devastating. Jeannie had the mental age of an 18-month-old infant, unable to talk. But to science, she offered a unique opportunity, a chance to separate the effects of nature and nurture on a child's brain. The big question was, would Jeannie be able to catch up? Susie Curtis was a young linguist when she got the job of looking after Jeannie 5 days a week.
She was hard to be with. She did not know how to swallow very well, so she would salivate and just spit. So I would come home drenched in her saliva. There were lots of things that were very, very difficult and unpleasant, but nonetheless, she was just entirely captivating. The way she moved her hands, the way she just moved her body and her face, her eyes that just seemed to be incredibly expressive and hold the world within them.
Susie soon discovered that Jeannie was highly intelligent and extremely curious about the world.
I was really hopeful because she was just insatiable. She wanted to know the word for everything. And her assumption was that everything had its own label. Every shade of color had its own label. And so she wanted to learn the label for everything in her world. She continued to develop a huge vocabulary. I could no longer keep track of what she knew. And she continued to be able to string words together. Buy applesauce store, or buy more applesauce store, which meant buy more applesauce at the store. Let me see, the log? But the little bits and pieces of English that take those words and transform them into a grammatical sense never came in. All the question words like who, what, where, why, when, never. She never had any of them. Pronouns like he, she, it, they, him, her, not in her vocabulary.
You do it.
And so despite all the years I was with her, where I saw lots of growth in lots of other areas, she didn't ever learn the grammar of English.
Jeannie never worked out the fundamental rules of language. Her brain had missed a critical stage of its development. In the first years of life, the main job of the brain is to make sure all the brain cells are wired up correctly. Surprisingly, it's not just a matter of making connections, but cutting them. A 3-year-old has twice as many connections between brain cells as a grown-up, and they're jumbled and chaotic. To work properly, the brain must decide which connections to keep and which ones to cut. Trillions of connections need to be checked. So the brain uses a brutal but effective rule. Use it or lose it. Because Jeannie's parents hardly ever spoke to her, the parts of her brain responsible for grammar were not stimulated and were crippled for life. Jeannie's story did not have a happy ending. She went through a string of foster homes, was abused in one of them, and stopped talking altogether. She now lives in a care home in California. Jeannie's experience was extreme, but her case taught science that once a critical window of brain development has passed, there is no going back.
Now, something that we observed during this video is a case study, right? Because we have a very severe, very different case, something that was unique to her. So for instance, the fact that she was not exposed to language for a long time until she was almost 13, and she didn't have that normal development that the average child would have. So of course, this gave us an immense and in-depth understanding of a child's development, but unfortunately, that information cannot be generalized. It can actually not be used for the average person because the average person does not go through this part and this type of abuse and neglect. So yes, it provides a great understanding of, for example, the connections that we may have in early child development in our brain, but it cannot be generalized. So it does have its downfalls, but of course that would happen with any form of research. And as you will see in the rest of the slide.